Hello everyone, I hope you guys are doing well. Today we are going to discuss one more interesting JavaScript interview problem. So without any further delay, let's get started. So what's the problem statement for today? So today's problem statement is on Array.flat method. We are asked to write the polyfill for Array.flat. But to write the polyfill, we should first understand what does Array.flat do. So Array.flat method actually flattens the array elements. Flattens means it reduces the nesting of array. For an example, if we are given an input array which contains sub-arrays at any level or at any depth, and if I call the flat method on that, it returns me an array which has all the elements flattened, or basically there are no hierarchy or no sub-arrays inside that. So we should write a method flat which can take an array as an input, and it should also support a second parameter which is a depth parameter. Depth means it should flatten the array elements up to the given depth only. If I have sub arrays beyond that depth, those should not be flattened, those should become part of the output array as is. Let's understand this last statement which I said. So we have been given this an array as an input, and let's see the number of levels in that. So this outer array is a level 0, right? So this first element is at level 0, right? Then this second array is level 1, or to say depth 1, right? Then this third element is, yes, up to this. So this is again at level 1 or depth 1, right? Now this element starts at inside depth 1. So this element starts inside depth 1 only. So this becomes a depth 2, and if I had another element like this, then this becomes the depth 3, so and so on. So if I have been given this as an input and depth is given 1, then my outcome should be this. Basically my elements will be expanded, or my elements will be flattened up to a depth of 1 only. That means 4 will not be expanded, 4 will become as is as part of the outcome or the final array. And similarly, if I call the same array with the depth of 2, then all the elements up to the depth of 2 will be expanded or the flattened, then this become my outcome. I hope the problem statement makes sense. Now let's jump into the code. Cool. So this is what we have. So this flat method is something which we have to write, and there are some test cases for the given input, and that should match the outcome. And for matching the outcome, I am using the low dash is equal method for comparing the arrays if both the arrays are same or not. Right now all the test cases are failing because flattening is not happening. Here I am trying to flatten this array, right, and I am matching it with the outcome, but it is not matching. That is why all the test cases are failing here. So here we have 4 test cases. Here the given input without any depth parameter, here the depth is given as 1, here the depth is given as 2, and here the depth is given infinity, and also the input parameter or the input array has multiple level of the sub arrays, or the depth is at multiple levels. And because I have given infinity, that means all the levels will be expanded, or all the elements at any depth will be flattened. Cool. I hope this makes sense. Now let's jump into the code. So at first we will handle the scenario when our given input is not valid, and for that I can check if the array is not of type array, right, array, or array dot length. There are no elements in the array. If any of the case is there, whatever we are receiving as an input, return that. Else array dot, we can start with the reduce method, because reduce method has a accumulator which keeps on building the final outcome, or which keeps on building the final array and the current element in the array, right, and I will initialize my accumulator with a blank array. and this I think we can remove because we are returning the outcome of this reduce only. And I will return ACC from here or the accumulator from here. Now we will write the logic to push element to this accumulator. Now let's analyze this. So if my input is of type non-array or it's a simple element, then it directly becomes a part of the outcome or the output array. And here as well we can see if it's a type of non-array, then it becomes part of the outcome array as is. So one condition is that. Second is, if my element or the depth is greater than the provided depth, then that element also becomes a part of the outcome array as is. That also we need not to process. So let's implement these two conditions here. If array dot is array, if the element of type array and depth still exists, so we will do something here, right? Rest all types of elements we can directly push to ACC. So basically we can directly push to our current item which is looping through. This makes sense? So basically we need to handle only those items which are of type array and for which depth is still valid, only those we need to handle here. And how we will handle here? ACC dot push, we will recursively call this method flat, and whatever will be the outcome of that, we will flatten that, or we will push all those elements to this ACC or the accumulator. And this time I will pass the sub array and I will reduce the depth by 1. So this we will keep on calling recursively, right? And this I can remove. So that should insert the elements to the accumulator, and our final outcome will be returned to the caller which is here. And let's see if our test cases are passing now. Yes, so our all test cases are passed now. So flat of 1 2 3 4 without any parameter is the depth 1 because it's a default value of depth. So it is giving 1 2 3 4 as the outcome, and if I supply 1, then also the outcome is the same. If I supply 2 as the depth, then outcome is 1 2 3 4. And if I have at any level depth of any level as an input array and I pass infinity as a depth, then it expand all the levels and our test cases are passing. So I hope today's problem was insightful. You really enjoyed solving the problem or understanding the problem statement. If so, you can support our channel by like, share and subscribe. I am your friend Manish, and thanks for watching.